Hope you got some energy from the coffee. Before we begin, I will request you all to go to menti.com and punch in the code that is 13795127. That is on the top of the slides. So it will help me to interact with you and ask you questions. I want this to be really interactive session. Sadly, I cannot ask each and every one of you. So I'm just using Menti to interact with you. So once you go to menti.com, punch in the codes 13795127. Once you go there, there would be some instructions in the screen. Right now, it should say, have you heard about Cython? Just to get a gist of it. OK, perfect. Cool. Let's begin. I'll request you to share your experience level in Menti, and I'll begin. So this is the agenda. And I think the first thing is, what is the difference between CPython and Cython? I was talking to a lot of folks today here, and a lot of them got confused between CPython and Cython. They are not at all the same thing. There's a difference, and because they are similar sounding, people get confused. Then we'll do a bit of deep dive in Cython, compilation in Cython, what are Python objects and why we get rid of them, and then importing C inside Python. But I think it was covered today beautifully in the previous talk, so I'll talk very less about it. OK, so let me summarize this talk. The more precise the mind is, the more precise the decision. It's a philosophical thing that if you know what you need, it's very easy to get that, right? But in computer world, it's like more precise the data type, faster the code. It's the philosophy of computer and compilers. So I think this happens to all the Python developers when they are beginning to learn, and especially if they are coming from compiled languages. Like you read Python, it's so easy. Print is print, for is for, and you just start flying, right? And I really like this XKCD comic. But the major question is, what is Cython? What is CPython and Python? I'll start with what is CPython. CPython is the reference implementation of Python which we use in day-to-day life. There are different versions as well. There is Cython, there is IronPython, and then there is PyPy. But majorly, the most common one is CPython. And whenever we say Python, we mean CPython. To write this, the compiler for this, C programming is used. It's free open source. Coming to normal Python, like we know, right? We are in PyCon. It's a high-level interpreted language, which we use for web development, machine learning, data analysis. But what is Cython? It's a superset of Python, wherein we compile Python, which is, again, not very usual, to C code, and write high-performance code. So what's the usual Python processing flow look like? So we have a Py file that is compiled to a bytecode, which is PYC file. Interestingly, that bytecode is not platform dependent, it's platform independent. And then the PVM, that's Python virtual machine, which has all those capability of reading all those bytecode and then run the code. This all happens inside the Python interpreter. And it's a good mix of interpreted and then compiled code. But once we go to Cython, it changes. So in Cython, the major thing is we are taking the interpreted part, the interpreted and compiled part of Python, which is usually very slow, and then taking that and doing it beforehand so that our code is faster. And we'll get to details of it, how it's done, but it usually requires parse tree generation, AST generation, bytecode generation, then optimization, and then we end up with a code object. This is, you can imagine it to be like you live very, very far from your workplace and you travel daily and you commute daily, so you take a lot more time. But if you take your home very close to your workplace, every day you'll take a lot less time. And that's what Cython is doing, that all the time, which all the processing which can be done beforehand, it's trying to do it beforehand. Okay, but why combine them? They are having really complementary skills. So it's very beneficial if you combine complementary skills. C is static, Python is dynamic. Maybe I like more dynamic. C is compiled, Python is interpreted. C is very hard to read, Python is easier to read. But here comes the major difference, that C is very fast. But Python, as we know, one of the biggest drawbacks is it's slow if you don't use it correctly. So writing suboptimal code in Python is relatively easier. Yeah, I've used this meme. This is exactly what happens in a Python developer's mind, because once you are in the Python ecosystem, you still want to read the code, but you want to leverage all the C power. Okay, so again, I went into it, but I read a lot of processes, but let's try to understand it from code standpoint. So py file or pyx file is compiled into .c, and then .c is converted to a object file, and then there is shared object file, and we take that shared object inside our Python code. So I'll walk through some of the code. I'm really sorry, I don't think so it's visible, but I also have a IPython notebook, which is a lot more visible. So we'll do things step by step to see which steps are the most impactful ones. So the first step is changing your Python extension to pyx. So Cython actually works with the pyx extension, not the py extension. It's like the advanced version of py. So in the first pass, we will not do anything. We'll not change anything. We'll just change from py to pyx. It means we are just doing the bare minimum. And in the next steps, we'll introduce some data types, which again are interesting from a Python standpoint, because Python is dynamic, but we are introducing data types here. In next step, we are introducing data types as well as returning some data types and mentioning it on top of like function alongside the function. So this add function returns an integer data type. And then we are completely removing the dependency on Python and totally going to C, and I'll talk more about it. Okay, yeah. So let's go to the code demo. Can you see it clearly? Okay. So this is. Just give me a sec. Just give me a second. Yeah. So this is Jupyter Notebook, and I am loading Cython here. There are multiple ways to compile Cython code. We just are utilizing Jupyter Notebook. It's easier, and we'll get into the details of it. What are the other ways? But as discussed, first code. This is the version 0 code. This is in Python, pure Python. There is no Cython involved here. But the next code, I have added some flags so that it gets compiled rightly in Jupyter Notebook. And again, this is the exact same code, but one is compiled and one is not, and we'll see. Okay, and once we compile it, the good thing is we get a very good output, wherein you can see there are yellow lines, right? So these yellow lines mention all the Python interactions which we do in Cython, which makes the codes slower. You can see there are, you can also try to read all these Python interactions. It's a lot more gibberish, but once you try reading out, you can see there are a lot of object initializations and a lot of if statements, and we'll slowly try to understand what it says. Okay. So let's time it and let's understand. We did not change anything. We are keeping everything the same. What's the speed up looks like? Okay, we get a 1.2 times speed up, which is not a lot, but given the fact we have not done anything, it's good. Now, the next step, if you remember, was this. We just introduced data types here. Nothing complicated. We just introduced them, and now we'll be compiling the code. You can see the difference from above, right? Above, there were a lot more yellow lines. Now there are a lot less yellow lines because we are not utilizing Python objects. Rather, we are utilizing native C data types. And I have cherry-picked the examples so that so that it gives you the impression that the speedup is very high. Sometimes it is, sometimes not. Depends on a lot of examples. But I really want you to get inspired by the speedup and try this yourself. Any random guesses what could be the speedup looking like here? 2 times, 2 times, 5 times. Okay. Okay. Can you see the speedup? Yeah. So I have not done anything. It's just cherry-picked the examples, but it's approximately 7,000 times. And we'll get to the details of it, why it's 7,000 times. I'd just like to remind everyone that, okay, I'll probably remind later, but yeah. Anyone remembers what we did, what was the third step? The third step was defining the return data type. So over here, there is no return data type, but now I just introduce the return data type. Okay, let's just do it. Let's compile it, and okay, now you can see there is only one dependency, and that is one yellow line, and we have got rid of all the yellow lines. The reason for that yellow line is because we are using cpdef. Cpdef means it's compatible with both C and Python. That's where CP comes from. The reason to do that, usually people stick to using cpdef compared to cdef is, and cdef is just you can call it only from C, not from Python. And people usually use cpdef because they want both the support. And but yeah, I think once I run this again, the speedup will, yeah, it will be a lot less because the numbers are very slow. But the bottom line is we get a very high speed up when we are moving from, when we are defining the data types. But once you do all the definitions of data types, slowly and slowly, you get to plateau. So I introduced cpdef and it was fairly, it was not giving a lot more speed ups. Okay. Okay. And as I was mentioning about cdef you can only call from Cython code. You cannot call it inside Python code. So we usually wrap it inside the Cython and then call it from Python. You can see over here, I've wrapped it and I'm calling it from Python code. Yeah. Yep. Yeah. You can see whenever I'm doing Python, it's a lot more yellow. Okay. And you can see now the speedups have kind of plateaued. Okay, this is some performance stats, and you can see like pure Cython is pretty high. Okay, it's again a comic from XKCD. It's a very popular online comic. I think a lot of you might have seen it before. So a legal excuse for a programmer is always my Docker is building, I'm compiling, or and I'm a machine learning engineer, my models are getting trained. Okay, and then that's the time when you take and go coffee. Okay, so there are some ways to compile Cython. One is manual way. It's good if you want when you are learning, but definitely not preferred way whenever you are doing things on scale. IPython is good. Again, I utilize a lot of IPython with Cython. It's very easy as I demonstrated. It gives you speed up. You don't need to worry a lot about setting up compilation. And then there are dist tools and setup tools, which are the usual way of compilations in Python. And then there is a pyx import. So pyx import it's interesting where it's trying to compile like just-in-time compilation inside Cython. So some best of both worlds, but again, it's not really recommended in production environments. But the real question is why Cython is faster. We'll get into it, but I'll just like to remind you, there is some new folks. So I'm interacting via menti.com. The code is mentioned on the top. That is 13795127. Once you go in menti.com and punch in this code, you can interact and you can ask questions there. So yeah, so what is the limit of Python integers? Anyone, any guesses? It's like, yeah, and it baffles my mind always that Python integers, I can say it's bounded by RAM. It's not bounded by your machine. That's really, really different when we come from C, Java. In C, you always know what's the limit. There's a limit attached to machine. In Java as well, similar. But Python is really different language when it comes to this. And you can see the example. A is a very big number. B is 0.0. When I'm adding A plus A, it shows me the answer. But if I'm adding A plus B, which is a very big number, and just 0, it shows overflow error. Can someone tell me why that's the case? But then I'm getting an overflow error. So anyone else want to try? It's bigger than the biggest float that can be stored. Yeah, that's absolutely correct. Now, it's the very confusing part that float has a limit in Python, but int doesn't. So very, very different. And sometimes when you are doing a lot bigger calculations, scientific calculations, you tend to hit this limit. But anyone knows why this is the case? Yeah, the implementations of float are usually a lot more complicated and they have limited it. But yeah, but we'll get a bit into details of how addition happens in Python as well in a bit. So one of the crazy part about Python is in Python everything is an object. There are some pros and some cons to it, and I'll focus majorly on cons. So as everything is an object, basically everything in Python is a Py object, be it function, be it numbers, be it strings. And that's why Python supports dynamically typed, it's a dynamically typed language. But this dynamically typed thing introduces a lot of overhead to the system. So operations in Python are slower. One of the major reasons is it involves a lot of lookup of type information and checking the bounds and n number of things which you need to do because you don't want to end up doing wrong things. One of the examples is if you write Python int 5 plus int 5, like 5 plus 5, the answer would be 10, but it's a string 5 plus 5, the answer would be 55. So Python tries to identify that data type, and then it does the calculation based on that. But it tries to capture that process always. Like it's not that it all happens in runtime. It doesn't happen in compile time. Like Python in the runtime only, it tries to identify what data type it is, and then what data type it is compatible with, and it tries to add those things. And yeah, as I was telling about Py objects. So Py objects is the basic data type of Python. It's really hidden underneath the CPython implementation. wherein it has a pointer to the object type information. It has the reference count of the object, how many times that object has been initialized. And it also has some overhead, basically used for debugging. So what I'm trying to say is, what looks like an normal integer to us has a lot more things attached to it. And I'll show you this addition in Python. Is it visible? Probably. So this is a very big number in Python. And what I've done is I have broken them in similar sized buckets. Okay? And you can see I'm adding it one by one. And if there is a carry, I'm also adding the carry, but I'm adding it one by one. And that's usually happens in whenever we are adding two numbers in Python. Now, it doesn't look very straight, but there can be a loop, like you're doing a for loop and you're doing an addition, and you might feel it's an n code, like order of complexity n. But there can be a possibility that there is another for loop, which actually depends on the biggest number which is present. So if suppose the number is pretty huge, it will do a pass of all of them and then add. Again, makes things slower, but sometimes needed. And you can see the results, like it's taking from previous carry and then adding. So it's doing this addition. And I made this using Claude's artifacts. Okay, so, and you need to do so many things in Python, like in the background. But sometimes you just don't care. You just want to be faster. I was talking to Joe yesterday, and he mentioned that the reason he likes Python is you can do so many quick, computations, anything you want to do quick, POCs, scripts. Python is really a great language. But in machine learning, many a times you do a lot of calculations, and when you try to do it in Python, it becomes a lot slower. And if you use Cython, it can be made quick fairly easily. So as mentioned, we directly map the C types like int double in Python and make it static. And that makes the memory usage a lot more predictable. And overall, your memory footprint is lower and helps in numeric computations. And one more thing that it helps is with avoiding GIL. GIL, I think, is a global interpreted lock, wherein Python actually runs only one code in multi-threaded environment. I'll show some demonstration. So this is how usually threading works inside Python. So it goes from one to other. So it's essentially is not very multi-threaded. But if you use Cython, so you usually go this, wherein your no-GIL section is continuously being processed, but then you still are attaching different cores, but the no-GIL section or your computation part can still work faster. And I'll do a quick code demo regarding it as well. So I'm doing some calculations like sine, cos, a lot of times, I think around 1 million times. And you can see this is htop, and I'm basically utilizing just one thread, basically utilizing just one core, not all the cores. You can see there's just one core which is higher, and I'm still waiting. And the result is around 3.098, right? If I use Cython here, and do it, any guesses how much time it will take? Less. Yeah, that's the correct answer. And it just took 0.45 seconds. And it helps me a lot to identify my bottlenecks in my code and just do it quicker. And you can see the answer. I'm not sure if it's visible. Yeah, it's pretty visible now. You can see, is that the same or different? What do you think? Yeah, but do you think you will care? So there are scientific calculations where you might care, but if like first 6 decimal places are same, sometimes you just don't care, right? But you care a lot more about time taken whenever you are doing a lot of repetitive small experiments, right? I'll also showcase one more thing. I'm running it now a lot more times, but want to showcase visually how does it look like. Now you can see my utilization, CPU utilization. You can see the course, yeah. It occurs in 3 seconds, that's the problem. But you can see now all the cores are being utilized, and you can visually see that. So I'll really suggest, like, whenever you are utilizing Python, play a lot around profiling tools, htop, profile your memory. There is bpytop as well, which I really like. So once you stare those logs and those tools, it helps you to identify what are the bottlenecks in your tool. Okay, so I think this was covered today extensively as well. But other benefit of Python is importing C inside Python. So whenever you are importing C inside Python, you need to do a lot of housekeeping items around like Python, especially about the objects. So left is, I know it's not very much visible, I can give you a base walkthrough. Left is a simple greet function in C, but then I'm importing that inside inside a lot of wrappers to import it inside Python. But you can easily do it in Cython, wherein you just define using cdef, and then you take it inside Python, which makes things a lot more maintainable. Will there be an overhead? Yes, but it depends how much you care. So who uses it? So I think whenever we talk about machine learning, pandas, numpy, scikit-learn are always there, and these guys utilize it a lot. There was talk about wheels today, just previous to this talk, and I was really enjoying it because I always saw whenever wheels are getting downloaded, they mention, like, we saw the convention today, and I always wonder, okay, why it is saying the OS name? Python is OS dependent, why there is OS name? So one of the major reasons is they also utilize Cython, and you precompile a lot of binaries to be compatible with that environment. So yeah, and that's how I came to know there is a thing called Cython, and that's how I started utilizing it. I just feel like it saves my time. So conclusions. So yeah, Cython bridges the gap between Python's ease and C's speed, which sometimes is necessary. And I think it's really a powerful tool if you are doing a lot of computations, especially scientific computations. I think that's it from my end. Thank you. You can find me in GitHub. It's the slides and all the codes, whatever I've used, are there in GitHub. I've also added some more tools just to play around. And you can also visit my website and connect with me in LinkedIn. Thank you.
We are right on time. Anybody have any questions?
Thank you for the awesome talk. It was really interesting to see how Cython can be useful. I wanted to understand from your experience, when we have a large team who is mainly using Python and they do not know of this Cython performance improvement, any suggestions on how we can use this still, and the team can continue using Python and still use Cython within the library, like keeping some abstraction or creating some libraries, like in a large project where people already prefer Python and they do not know Cython? Any suggestions on that, or trying to adapt Cython in your library?
I think Cython adoption is fairly easier if you are doing calculations, right? And I showed you the code. You can read it, right? There are a lot of, you'll say, talks like this, wherein they mention how the journey is. Sometimes you do fell into problems of compilation and things like that, but it is fairly easy to use. So if you just, if one of the person just started utilizing it and showcase the speed ups, I think it tends to get people interested. And that was my agenda as well, to get people interested and start utilizing it, because it's very easy to learn. I think probably 2 days, 3 days, you can get the most of the gist and just start utilizing it. I think that's the best way to learn that.
Got it. Thank you.
Any more questions?
Yeah, thanks very much for the really good talk. I just wanted to ask, it seemed like with Cython you generate C code, and I'm wondering whether if you ship something on PyPI, whether you should ship it with the C code or with the PyX code?
Okay, so we don't, so C code is the auto-generated code, and I was also showing you it was happening in the backend even with Jupyter notebooks. So while shipping it, one of the things that you need to do is compile it correctly. That's usually a lot more platform dependent thing. And you face a lot of issues around it. But if you know fairly how CMake works and how you usually compile things, things get easier. But still, I think compilation is the most painful part of Cython and maintaining those binaries.
Thank you.
Any questions?
Hello, thanks for the talk. There's a slide that you run the computation and there's two results, one with Cython and one without. And the value are slightly different. So I wonder the underlying reason, and is it possible to address that?
The slide regarding the performance?
Yeah, could you go back?
No. I think you meant this. Just a sec. I think this one, right? The results.
Yeah. You just got the result, right?
Yeah.
And the value is different.
Yes, because we changed the data types. So Python is the more accurate one. It uses the exact numbers, and the float representation of Python is a lot bigger than the normal C one. So it's just that the way you represent the like you store your numbers in a lot bigger data type. So it's more
the data
accurate.
type double?
Yeah.
So
Yep,
I
yep.
mean, if both are double, why they are different?
I don't think so. I've used double, but I don't know the exact reason for it. But it is around that the numbers in Python are a lot bigger and they are better represented.
I see. Okay. Thanks.
Thank you.
Thank you very much for your presentation. So I have a question. So in my understanding, so Cython is using GCC or cron. So can we know what kind of optimization flags are used for GCC or cron? And can we control optimization flag for GCC and cron? So
Yes.
O3, MTune, or
I'll just give me a second. I've added the compilation thing in my Git as well. So yes, you can do it from Python, and you can do it using this, and you can play with the compilation flags, and it is totally usually independent from what we do in Python. And again, reiterating the fact that compilation over here is usually the harder step than writing the code.
So we are right on time. if anybody have any more questions, Abhik will be around. He can take questions offline. You can meet him in hallway or other side in this room. Having said that, once again, thank you so much, Abhik, for clearing all those concerns and about Cython, and thank you so much.